Okay, so I got that fixed. I'm in my SIO209/lessons folder, and we're gonna do we're gonna go to lesson 10, copy that raw format link, and then do curl-o, and then we're gonna source activate Python 3, and we're gonna do Jupyter Notebook. And go ahead and click on lesson 10. Alright. So today we're going to cover Numpy, and then we're going to have a Pandas and Matplotlib crash course, which is a very quick introduction to Pandas and Matplotlib, but most of the lesson is going to be a more dedicated treatment of Numpy. So Numpy is the numerical Python. That's what the name comes from. And this is a very advanced package for doing arrays, matrices, numerical computing of various kinds. And it's a very sort of rapid way to do numerical analysis, much better than using the lists and kind of things that we've already talked about. So there's some readings here, and then a table of contents. So let's get into Numpy. And so the other thing I wanted to say was that Pandas and Matplotlib, especially Pandas, are built on top of Numpy. So although in a lot of the things we'll do in data science with Python, we'll use Pandas, underlying all of this is Numpy, and so it's good to have some understanding of how it works, and a lot of the things you can do with Pandas you can do in Numpy, but generally we'll use the Pandas versions of these things. So we're going to talk about 3 different data types mainly today. There's the Numpy ND array, or n-dimensional array, and then the Pandas series and data frame are sort of built on top of the ND array. Again, these have many of the properties of lists, but they're more powerful. And the reason that Numpy is so fast is that it's implemented in C and Fortran. So it is able to, when you're using certain types of vectorized calculations, its performance is very good. So first thing we're going to do is import Numpy as NP. And so what this means is that well, first of all, we have Numpy already installed, because when we installed Pandas earlier in the class, it gave us Numpy also. And then when we import Numpy, we're saying import Numpy and all the functions and methods, etc., that it gives us as NP. So whenever we want to use Numpy, we just type NP. We don't have to type out. So we'll see this a lot. We'll use Numpy as PD and Pandas as PD, etc. So there's some shortcuts that we use. So the main data type in Numpy is the Numpy array, or ND array. And there's different ways we can make this. We can convert from a list or a tuple. We can use functions that generate the arrays, like arange or Linspace, or we can read data from files. So first we're going to see how we can make an array from a list. So here we have a list of integers, and then we're going to, that's in brackets, and then that's going to be wrapped in this np.array method. And so now we have this thing v, which is an array that has these values. Similarly, we can take a nested list or a list of lists to make a matrix, which is also called an array. The reason these are both called array is because it's an n-dimensional array. So it can either have 1 dimension, or 2 dimensions, or 3, or 4, etc. So the first one was a 1-dimensional array. The second one is a 2-dimensional array. And so if we use this type function, we can see that both of these things we just made, v and m, are both Numpy ND array. So again, V was a one-dimensional array, so it has shape 4, and then that's it. M has shape 2 by 2. So this is like using the length or the len function that we use with lists. If we just want the total number of elements, we can use the size property or attribute. So one thing to point out with Python is sometimes you'll see parentheses after this like kind of command, and sometimes there's no parentheses. So the reason that is if it's a function or what we call a method. If it's a function that works on an object, it's called a method. Those will have parentheses because that's it's performing some function on that object, and maybe it takes inputs also. But this is more like an attribute or a property of the object, so there's no parentheses. It's just there's various things that property has. So you can see, like, for example, we type m dot and then tab. Some of these are going to be attributes, and some of these are methods. So you can try those out and see, kind of figure out which ones are which.
Why is it that sometimes like the parentheses does something? Like I think for your data frames, like you put parentheses, it'll give you something different than if you don't put parentheses.
Right. So sometimes if you let's see if I can find an example here.
Yeah, if it's not right now.
So if you type the function without any parentheses, it'll just say, hey, that's a function. It'll tell you what it is. But if you type, and then I don't.
So what is the name of itself? Is it just giving you the function and then it prints out without parentheses?
Yes. So that's just say. So the value of that expression is the function, is just,
okay.
Hey, this is a function. So it doesn't give you an error, but it also doesn't execute the function. It's yeah. And there might be other examples that it worked a little differently. Maybe we'll come across those as we go. Okay, but so we have shape and size. We can also get the shape using a NumPy function. So shape is an attribute of V and an attribute of M because those are NumPy arrays. But we can also say, I want to take the NumPy function shape and run that on M. And that'll give us the same output, and the size gives us the same output we had before, but it works a little differently. So in one it's like a method or an attribute, a method of the object, or I guess in this case it's an attribute of the object. In this case it's a function of NumPy. So two different ways to get the same answer in this case. Question?
So I noticed that when I add a bracket to V and I use V dot shape, it gives me 4, 1 rather than just 4, can you go back to the cell? Okay. Yeah.
Yeah.
There is no 1 after the comma. No, I'm 5.
Yeah.
And what's the difference between M and V? Because I noticed that there are 2 brackets in M, but there are only 1 in V.
So the difference here, this versus this.
Yes.
So this one is we passed a nested list or a list of lists. So it's it becomes a two-dimensional array. So this is the first element, which is itself a list, and this is the second element, which is itself also a list. So it becomes like a matrix. So that's why this one has shape 2 by 2. This is the first dimension. This is the second dimension. Whereas this one only has 1 dimension. Okay. So you might be asking why, these look like lists. Why would I use ND arrays instead of lists? Well, we talked a little bit about this when we talked about lists. So this first reason is that Python lists are very general. So they can contain any kind of object, and they're dynamically typed. So as you add things to the list, Python will kind of figure out what types those are, and so it can support. Even though we said you really shouldn't use you shouldn't use a string as the first element and an integer as the second element and another list as a third element of a list, you can legally do that. However, in NumPy you can't do that. Everything in the list has to be the same kind of thing. And so the list has a data type. Now this restricts you, but the reason it's good is because it speeds things up. So this is what it means how the NumPy arrays are statically typed. So static means it can't be changed. That type of that array is set when you create it, and that gives you benefits in terms of speed and functionality. So they're statically typed and they're homogeneous. That gives them memory efficiency, and it gives you fast implementations of certain functions. So if we want to know the type of the array, we can use this dtype property or attribute. So we type m.dtype, and it says it's an integer, 64. This just reminds me, I forgot to clear the output. So let's clear the output here. So let's go up to, let's go restart and clear output. That's going to restart the kernel and clear all the output. The restarting will then reset the numbering also, which is nice. Another thing we can do now is we can go to cell, and then we can say run all above. So this is going to run everything up to this point, because we already know those commands work. We already did those. We don't want to go through them one by one. So we can say run all above, and it's going to just run everything again. So that's handy. But we still have everything below as it hasn't been run, so we can be surprised. Okay, so this matrix that we created has data type integer. So if we uncomment this line and we try to put a string as the first element of the that ND array, that NumPy array, it's going to give us an error. You can't use the string where it's expecting an integer. But if we do want to set an integer there, that's no problem. So now we've put 5 instead of 1, and now we can see that m has been changed. So this is using this positional based indexing. So array m at row 0, column 0, we're going to set to 5. And we'll talk a bit about sort of indexing and slicing in a minute. It works very similar to lists. And if we want to explicitly set the type of data when we create the array, we can use this dtype keyword argument, and we say its data type is complex. This works very similarly in pandas, so this is the kind of thing where this is useful. So we're going to say we want this two-dimensional array, and it's going to have data type complex, which is complex numbers. So if we execute that, we see we have 1, 2, 3, 4, and then it has this imaginary component, this j component, which in this case is 0 because these were formed from just regular integers. So the kind of data types that we have available are integer, float, complex, bool, and object. There's others, but these are the main ones. Object is another word for string. So when you see object as a data type, that means it's a string. And you can specify bit sizes if you want to get really, but generally letting the program figure it out for you is fine. Okay, so now there's some array generating functions that are useful. So we saw a few times in the class using this function range to get a range from 0 to that number, but not including that number. So range 5 would give us 0, 1, 2, 3, 4. So we have a NumPy function that works similarly, and it's called arange. but it has some more advanced features. So if we want to get a range from -1 to 1, and with a step size of 0.1, we can use this construct here. So I've put in comment here, this is start, stop, and step. So step is how much you change between each one. So here this is going to give us an array of floating point values, and you can see that because of the way that floating point values are stored in the computer, not all of these are exactly the number. So this one is actually 0, but it's not stored as 0 in the computer. It's stored as -2 times 10 to the -16th, which is, for all intents and purposes, 0. Anyway, so don't worry about that. So the data type of that array that we just created is a float. However, we can, if we pass integers as arguments, then the data type will be integers. In fact, let's do this to make it explicit. So you can see that now this second array we made has type integer instead of float. If we want to be explicit, we can pass an argument dtype equals float in this case to do the same thing we did here, but now we're getting this thing. And again, I'll make this more explicit. Okay, there's another function called Linspace. So with dtype, the stop that you give is not included. So here we said I want a range from 0 to 10 with step size 1. So we got 0 through 9. With Linspace, you do get the both ends, and instead of specifying a step size, you specify an n, which is the number of elements you want in that list. So this would actually be a better, this is a better example here. So if we wanted from 0 to 10 using all 10 elements, we can specify it like this. So there's another function called mesh grid, which is similar to, or it's called mgrid, which is similar to mesh grid in MATLAB if you're familiar with that. So if you want to make a set of sort of orthogonal matrices, you can use that. And there's also a variety of random number generating capabilities. So if you want a 5 by 5 array of random numbers, so by default these will be in the range from 0 to 1. You can do that, or if you want a normally distributed array, you can use rand_n instead of rand. So these will be a normally distributed distribution centered at 0. And if we want to see how this works, we can, I believe there's a way to change the center, but might not be with this function. But we can find out how it works using that question mark. If we want a diagonal matrix with everything else as zeros, we can use this diag function. If we want an array with zeros or ones, we can do this. And if we want as integers, we can specify the dtype as int. So zeros is a nice function to have. You can make an array that's all zeros, kind of normalized, and then you can start adding things to it.